Hey guys, this video will take up question 6 from the first assignment. Okay, so what is the setup? We're assuming that some a cubed, we can write it as b times c, where b and c have no common factors, a is non-zero, and our goal is to prove that b and c are both cubes. Okay. And the tool for this question is unique factorization for the integers. Okay. So first of all, write a, like uniquely factorize a as either, if a is positive, it'll be like this. If a is negative, we'll just put a minus. So I'll just put like a plus or minus. So I'll just put plus or minus 1 times, unique factorization says that we can write a uniquely as a product of powers of primes. So we'll write it as p1 to the a1, p2 to the a2, all the way down to pk to the ak, and a1, a2 up to ak are all integers greater than 0. Okay, so then a cubed, well, the prime factorization of a cubed, again, it's just plus or minus 1 times p1. Now it's p1 to the 3a1, p2 to the 3a2, pk to the 3ak. Okay. Now if we look at the prime factorizations of b and c, so we look at it. So if we look at p1 to the 3a1, okay, we know that p1 to the 3a1 has to occur in b times c. But since b and c have no common factors, all the p1s have to go into either b or all into c. So since the GCD of b and c is 1, either p1 to the 3a1 occurs in b or c, right? So you don't have a p1 in b and then the rest of the exponents coming, like the rest of the p1s occurring in c. It all occurs in b or all occurs in c. And the same for all the pi's. Okay. Okay, and I'll just say the same goes for p2 to the 3a2, and all the way up to pk to the 3ak. And when you work it all out, well, what happens? Well, the exponent in the prime factorizations of b and c, they all have a 3 occurring in them. Okay. So if we rearrange, or I shouldn't say rearranging, but like if we rename the pi's, we rename them if necessary, so that we can write b equals p1 to the 3a1 all the way up to pj to the 3aj, and then c is pj plus 1 to the 3aj plus 1 all the way up to pk to the 3ak. And notice these are both cubes. This is just p1 to the A1, all the way up to PJ to the AJ cubed, and C. Oh yeah, I guess I should put like we could have plus or minuses in front of B's, front of B and C, and then similarly we have C equals plus or minus PJ plus 1 to the AJ plus 1, all the way up to PK to the AK, all cubed. Well, here I should put a plus or minus inside, and I should do likewise for C. Of course, -1 cubed is just -1, so this is fine. Okay, and that's the end of that question. Okay, so let me know if you have any questions about that. Thank you for watching.